Okay, this is a 2013 Project Schools paper, Junior Cert, higher. Okay, so what we get first is the column in the table below represents the following set of numbers: natural numbers, integers, rational numbers, irrational numbers, and real numbers. Complete the table writing yes or no into each box indicated when the number is √5, 8, -4, 3.5, 3 pi over 4, or is an element of each, is or is not an element of each box. Okay, so trying to explain first and foremost what exactly does each section mean. Okay, well, natural numbers means numbers above 1, okay, or sorry, 1 and above 0, that are basically whole numbers and can't be fractions. Okay, integers, which is said, can be numbers from anywhere from, it can be -1000, but it basically can be any minus number or any positive number, provided the number is a whole number. You're not allowed fractions, fractions and decimals. Okay, rational numbers are numbers that can be expressed in fractions. So for instance, a rational number would be something like 7/2, -1.5, -3/7. Okay, what's not in rational numbers is numbers that can't be written as a rational number. So irrational numbers are basically numbers that can't be written in the form of a fraction, like square roots. Okay, and maybe stuff like pi, because pi is a number that continues on forever. So you can see the number pi right in here, pi, and pi just keeps on going indefinitely. Okay, and it can't be expressed as a fraction. Well, if I had a 1 divided by 3, even though it keeps on going, 0.333333, it basically can be written as a third. Okay, so that's the difference between a rational and an irrational number. Irrational numbers can't be expressed by using the fraction button. So if you're ever worried in the test whether it works or not, you just press this button here, and if you can't turn it into a fraction, then it can't be isn't a rational number. Okay, so let's begin. √5 is not a natural number, it's not an integer, it's not a rational number, it's an irrational number, and all numbers are real numbers. Okay, so for example, any of these numbers here are considered real numbers. Real numbers can be anything. It could be minus irrational numbers, plus rational numbers, it can be anything. Okay, 8 it's a natural number, 8 is an integer, 8 is a rational number. Now the reason why 8 is a rational number is it can be written as 8/1, which is a fraction. Okay, is 8 an irrational number? No. Is it a real number? Yes. -4 is not a natural number, it's an integer. Is -4 a rational number? Yes, it is, because it can be -4/1. Is it an irrational number? No, because it's a rational number. Is it a real number? Yes. Finally, 3.5. Okay, so 3.5. So we write down 3.5 here. And 2. 7/2. Okay, rational numbers can be written as fractions. Okay, so because it is a rational number, but it's a fraction, so it's not n, it's not an integer, it's a rational number, it's not an irrational number, and it's a real number. Finally, the last one, 3 pi over 4. So there's 3 pi over 4. Now we can see that we can't write it as a rational number just using two ordinary numbers. Pi always has to be there. As I said earlier, pi is an irrational number, so 3/4 of pi is also an irrational number. So we're going to go no, 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 yes, and yes. Okay. In the case of √5, explain your choice in relation to the set of irrational numbers and give a reason for writing yes or no. √5 cannot be written as a fraction. And because it can't be written as a fraction, this means it's irrational. Okay, so in the case of root 5, explain choice relation to irrational numbers. Root 5 cannot be written as a fraction, therefore it is not a rational number. It's an irrational number. Okay, part 3. Using the properties of surds, show that root 98 minus root 18 plus 2 simplifies to 5 root 2. Well, the properties of surds is the following, okay? If I have root 98, I can break up root 98 into the following, okay? Now, always be aware of perfect squares when you're doing these numbers, okay? So 1, 4, 9, 16, 25, 36, 49, and try and break it up into one of these numbers if you can. Now, the properties of surds is that I can break up 98 into 2 multiplied by 49. So 98 is actually the same thing as root 49 multiplied by root 2. And root 49, root 2 is going to be 7 root 2. Okay, because root 49 is 7. Same thing. Okay. Next part then is going to be root 18. Now always remember that you can once again break it down into 18 can break down into root 9 times root 2, which in turn is 3 root 2, because root 9 is 3. Then if we put it into the original question, what we're going to get is 7 root 2 minus 3 root 2 plus root 2. And what it's like is, it's sort of like 7x minus 3x plus x. It's like 8x minus 3x, which is 5x. And in this case, it's 5 root 2. Now, alternatively, you could just put into your calculator root 98 is 7 root 2, root 18 is 3 root 2. So then you could just go about doing root 98 minus root 18. Plus root 2. Okay, 5 root 2. Under no circumstances are you allowed to do this. Root 10 minus root 5 equals root 5. It doesn't work like conventional maths, so you have to go about doing your rules. It only works conventionally when they all are in the same language. What I mean by the same language is these are all expressed in terms of root 2's. There's 7 root 2's minus 3 root 2's plus 1 root 2. They can't be combined unless they're all the same surd, okay, or all the same root. Okay. Question 2. U is 1, 2, 3, 4 all the way up to 12. P is a set of prime numbers less than 12. Now please remember what prime numbers are. Prime numbers are a set of numbers that only have themselves and the number 1 as a factor. So the number 1 is not included. Okay. So what we can get for the prime numbers is 2, because it's only 1 is 2 multiplied by 1, 3 multiplied by 1, 5 multiplied by 1, 7 multiplied by 1, 11 multiplied by 1. This is the only way you can get the following numbers: 2, 3, 5, 7 and 11. 9 is not a prime number because it can be written as 9 times 1 and 3 times 3. That's why 9 is not included. Okay, so now we have this list here for prime numbers: 2, 3, 5, 7 and 11. Now remember, they all have to be below 12. Okay, E is the set of even numbers. So this is P. This is E, even numbers. So less than 12, not less than or equal to, less than 12, right? So it's going to be 2, 4, 6, 8 and 10. 12 is not included because it's less than, okay? And O is the set of odd numbers less than 12, so O equals 1, 3, 5, 7, 9 and 11. Okay, so let's see. First of all, is there any numbers that are present in all 3 sets? So is there anything here in the middle? Well, as you can see, there's no even. 1 is a set of even numbers, 1 is a set of odd numbers. They have nothing in common, therefore there can be nothing in the middle of all three. Okay. Now, the next part is, what about P intersection E? Well, they have 2 in common. They have the only one they have in common is 2. So 2 goes in here. Okay. And what about the next one? We'll just make this slightly bigger. Okay. Okay, so that's it there. Just leaving out the number 2. Okay, so the number 2 goes here. Okay, next one is, what do P and E have in common? Just the number 2. Number 2 is now gone. What do P and O have in common? Well, they have the number 3 in common. They have the number 5 in common. They have the number 7 in common. And they also have the number 11 in common. So this is going to be 3, 5, 7 and 11. Okay. Let's write down all the even numbers remaining. Numbers that are only even is going to be 4, 6, 8 and 10. There is no overlap between even and odd because there's no such thing. Now we only have the odd numbers remaining, which are 1 and 9. Okay, and there's no prime numbers that are prime numbers only, because prime numbers either have to be even or odd. That's why there's nothing in here. Name any set on this diagram after part A has been completed that is a null set. Okay, a null set would be P only. Okay, so P less E union O. Everything in P that's not in E union O. Everything in P that's not allowed to be in anything else. That's a null set. Another null set would be the intersection of all three. P intersection E intersection O, which would be this section here. Okay, that's also a null set. And then another null set would be E intersection O, that full part there. So there's 3 null sets. Okay. If a number is drawn at random from set P, what is the probability that it's even? Well, how many numbers are in P? So we have 1, 2, 3, 4, 5. There are 5 numbers in P. It only has 1 even number. So the answer is 1 out of 5. Okay. Alright guys, now we're on 3A. For the diagrams 1 and 2 below, shade in the named region. Well, the first region is everything that's common in A, B and C. So that is dead center. A intersection B intersection C. The next one is everything that's in A intersection B but cannot be allowed in C. So it's not allowed to be in C. That's what less C means. Can't be allowed in C. So just gotta get rid of this part here. And that's our answer there. Okay. Next part. The box on the right contains 6 statements. Note P dash is the complement of set P. A number of statements are incorrect. Write down one incorrect statement. Okay. Let's make this a bit bigger. Okay, so let's begin, whether it's true or false. Okay, so what we're going to do is we're going to make 2 sets and 3 sets respectively, 2 diagrams to prove all of these points here. Okay, now it only says give an example. Only wants one correct statement, but I'm gonna do all 6 just to show you what's going on. Okay, so there's the first one, and then we're gonna have a triple diagram over here. Okay, So let's start off with A. Okay, so this is A union B. Okay, it's the same as B union A. This is true because, for example, if I had something like this, okay, A union B is everything in both of them, and B union A is also everything in B and A. So both of them are true. Okay. Now, the next one is if A union B union C is the same thing as A union B union C. So let's figure this out. Okay, so I'll just put some numbers in here again. Okay, and let's figure this out. Okay, so in this given example here, A union B is, we're just going to do this part here first. A union B is everything in here. Okay, and then it wants everything in C as well. So therefore it's also going to include everything in C. Okay, and then the next one is everything in A union everything that's in B and C. B and C. So everything in B and C is what's here in this green region, and then you also want everything that's in A, so it turns out to be the full thing as well. So the two of them are equal, they're both true. Okay, so that's true. The next one, everything in A that's not in B, that's not in C, is the same thing as everything that's in A that's not in what's in B but not in C. Okay, so that's a bit of a difficult question to do, so we're going to try this one here. Okay, so let's write down this. Everything in A that's not in B. Well, everything in A that's not in B is going to be 1, 2 and 4. Okay, okay, so 1, 2 and 4. Then everything that's in this region also cannot be in C. So that region I just had there a second ago, it also cannot be in C. So there we go. So A, we have to take out the number 4. Okay, to make this work. Okay, so we got to take out the number 4 to make this work. Okay, so what we're going to do next is we're going to just take out the number 4 because it's not allowed to be in the example. So what we're going to get here is everything that's in A but that's not in B, which can also not be in C, is the answer 1 and 2. Okay, the second one, which is here, is everything. We're going to get what's in the brackets first, so we're going to get B less C first. Everything in B that's not in C. So everything in B that's not in C is going to be the numbers 3 and 6 because it's not allowed in C. B less C equals 3 and 6. Okay. Okay, and then you want everything that's in A but is not in the set B less C. So I want everything in A that's not 3 and 6. So it's going to be 1, 2, 4 and 5 because I'm not allowed 3 and 6. So everything in A that's less than B less C is equal to 1, 2, 4 and 5 because we're not allowed to have 3 or 6 in this answer. Okay, so I'm just after proving that this one here is false because I'm not allowed it. Okay, because to prove it's false, make up a bunch of numbers and then write down what the sets are, and if the sets don't match up, we can clearly see that this part here is not equal to this part here. Okay, next part. A union B. A intersection B complement, I think, because it has that dot there. is the same thing as everything in U that's not in A and B. So let's figure this out. So the first thing we need here is we need a U being the universal set, okay? So we're going to put a rectangle around this, or box around this, and this can represent U. And we'll put a number outside U. We'll put the numbers 7 and 8 outside, okay? Now that that's done, we got to figure this out, okay? So everything that's in A intersection B complement. Okay, so A intersection B complement. Now we're using the example to the left here. Okay, A intersection B complement is going to be everything that's A intersection B is this, but everything outside it. So it's going to be 1, 2, 5, 6, 7, and 8. Okay, that's A intersection B complement, done. The next one is everything that's in U that's not in A intersection B. So I write down A intersection B is 3 and 4. So you're allowed to have everything inside U that's not 3 and 4. So once again it's going to turn out to be U less everything in U that's not in A intersection B is going to be 1, 2, 5, 6, 7, and 8. Both answers match up. This one here is true. Okay, next one. A less B is the same as B less A. Everything in A that's not in B is the same thing as everything in B that's not in A. So let's figure this out. Using the example to my left here that I'm circling at the moment, this example here, what we're going to say is that A less B is everything in A that's not in B, and we know that's only going to be 1 and 2 because 3, 4, 5, 6 is in B. And then everything in B that's not in A is going to be only 5 and 6. So we just have to prove that this one here is false. Now finally, so write down one incorrect statement. You could use this one, so any of these ones can be incorrect. Okay. Now finally the last one. Everything in B less A union C equals B union C less A less C. Okay, so the final one we got to prove is part 6, okay? And part 6 requires 3 sets, so I'm just going to get rid of this part here. Don't need it anymore. Okay, and let's see if this one turns out to be true. Everything in B that's not in A union C. So A union C is this part here, covered in red. And everything in B that's not in A union C is the number 6. So what we can write down is so simply the number 6. Everything in B that's not in A union C equals the number 6. Okay? And then finally, we have to do everything in B union C that's not in A, that's not in C. Okay, so B union C is this one here. And we can see all these ones here, and out of this list they're not allowed to be in A, so B union C is going to be 3, 4, 5, 6, 8, 9. B union C that's not in A is going to be everything in B union C that's not in A. We're going to get rid of the 3, the 5 and the 4. So we're left with we're only left with 6, 7, 8, 9. And then finally after that, it can also not be in C. So it's going to be B union C less A, and now it's also not allowed in C. Okay, and it's not allowed in C. We're not allowed 7, 8 or 9, and we're only left with the number 6. Hence this is true and they're equal to each other. Okay, so the next one is, a group of 38 students were asked if they've ever been to France or Spain. The number who had been to Spain was 3 more than the number who had been to both countries. Twice as many had been to France as Spain. 4 students had not been to either country. Find out how many had been to both countries. Okay, so what we need to do here is we need to set up a Venn diagram. Okay, so we'll have this one, this one here. Okay, so there's our Venn diagram, and then we'll have our class set on the outside. This rectangle represents the amount of people in the class. Now, oh sorry, France or Spain, sorry, 2 countries, excuse me. Okay, so what we're going to do is we're going to put out number 4 on the outside. We call this France, and we'll call this Spain. Okay, the number of a group of 38 students, so the full set has 38. They're asked if they've ever been to France or Spain. The number who had been to Spain only, so Spain only is in here, was 3 more than the number had been to both. So let x be the number that's been in both. 3 more went to Spain only, so that'll be that same number plus 3. And then finally, was 3 more than that had been both to both countries, so that information is now finished with. Twice as many had been to France as Spain. Okay, so the number of people that have been to Spain is the 2 of these added together. Okay, so that's going to be 2x plus 3. And now we got to multiply that by 2. And what we get there is 4x plus 6. Now please remember, this 4x plus 6 includes everything in France. Twice as many had been to France as to Spain. So it includes the x in the middle. So to get this part here on its own, we need to take away x. Okay? So what it actually should be is 3x plus 6. Okay? And now we're going to find out what happens in total. In total, the full thing should add up to 38. So we're going to get is 3x plus 6 plus x plus 3 plus 4 equals 38. Okay, let's see what we get. 3x plus x is 5x. 6 plus 3 is 9. 9 plus 4 is 13. 5x plus 13 equals 38. And the 13 over the other side comes minus 13. 5x equals 25. X equals 5. Find out how many had been to both countries. That's this value here, and it's 5. That's 8. And that's going to be 21. Which means 26 people went to France in total, and 13 went to Spain in total, which is twice. So the amount of people that went to France is twice that of the amount of people that went to Spain. Okay. Now, the minimum wage per hour for different categories of worker is shown on the table by law. By law, under 18 minimum wage is set at 70% of minimum wage for experienced adult worker. Verify that this is true for the rate shown on the table on the right. Okay, so let's find out. Okay, an experienced adult worker makes €8.65 per hour. If I multiply that by 70%, which is 70 over 100, we'll see what we'll get. Okay, so 8.65 multiplied by 70 over 100, because they should only make 70% of what the adult earns. And what we get here is 6.055. Now, by law, the minimum under 18 minimum wage is set at 70% of the minimum wage for the experienced adult worker. Okay, and if this is 6.06 correct to 2 decimal places, which means that the under 18 worker gets 70% of the adult worker. This is set as true. Okay? Now, part B. The government has decided that it's going to reduce all minimum wage rates by 6%. Calculate the new minimum wage for an experienced adult worker correct to 2 decimal places after this reduction. So he gets 8.65 per hour. This is 100%. We now want to find out what happens when you get reduced by 6%. When you get reduced by 6%, you end up on 94%. So 8.65, we're going to divide it by 100 to find out what 1% is, and then we're going to multiply it by 94 to find out what 94% is. So 8.65 divided by 100 multiplied by 94. And what we should get here is 8.131 or 8.13. So 8.13 euro per hour. Okay. John is an experienced adult worker. After the reduction, he says, if the minimum wage were to be increased by 6%, then I'd be back earning 8.65 euro per hour. Is John's statement correct? Okay, John's statement I think will not be correct, and I'll tell you why. His new wage is considered his 100%. His new wage at 100% is €8.13 an hour. We want to find out if he gets a 6% increase, he's going to be on 106%. So what we're going to do is we're going to divide by 100 and multiply by 106. Dividing by 100 gets you to 1%, multiplying by 106 gets you up to 106%. So we're going to get is 8.13 divided by 100 multiplied by 106, and what we get here is 8.62. Okay, and it's not as high as the original starting point, so it's going to be 8.62, but you got to remember you were on 8.65, so it is slightly less than what you were on. Okay, next question. Question 5. Two members of a soccer club wanted to find out their football pitch was being lined out properly. They have a 10-meter tape measure, a calculator, a pen and a paper. By using only these, explain how they could test if the angle at each corner is a right angle. Okay, so what they should do is they should start at a corner flag. Corner flag. Use the tape to measure. Use the tape to measure. Use the tape to measure a certain distance. Like certain distance along the sideline. Like 3 meters. Then measure a certain distance along the goal line, like 4 meters. So what we've done there is we've done the following, okay? We've gone with our tape measure and we've measured out this much here along the sideline, that's 3 meters. We've gone up, not to scale obviously guys, so this is 4 meters. Now what we're going to do next is we're going to measure the distance from these 2 points to each other using the tape measure. Okay, and it obeys Pythagoras Theorem, because Pythagoras Theorem is used for right angle triangles. And remember with Pythagoras Theorem, the longest side, which is the hypotenuse, equals the sum of the squares on the other two sides. So the Pythagoras, it should be like 4, 3 and x squared should be equal to 4 squared plus 3 squared. Okay, and that proves it's a right angle triangle. Okay, so what we're going to get next is then measure the distance between the endpoints. Okay, then measure the distance between the 2 points using Pythagoras Theorem. Using Pythagoras Theorem, see if the calculated distance is the same as the measured distance. Okay, so in a nutshell, you measure your 2 points, and then you have your 2 points here and here. You measure the distance between these 2 points, and then you use Pythagoras Theorem to see if calculate x using this method here is the same as the x you measured on the pitch. Okay. Part B. By using the trundle wheel, calculate a pen and paper. Explain how the two members could test if the center circle on the pitch really is a circle. Okay, guys. So what you need to know about circles is circles have a length. So the length of the circle is 2 pi r. Okay, so what you could do is you could measure from the center of the circle, or the kickoff spot, which is here. You could measure the diameter on both sides using your tape measure. Then you can half it to get the radius, and then using your trundle wheel you could find out how much distance it is to go from here all the way around in a circle, and that is L. So you can find out L using the trundle wheel, and then you can divide L by the 2 and the r, and you get pi. And if pi is correct as 3.14, then you know it's a circle. Okay, so we'll express that in writing. Okay, so let's begin with that. Okay, use the trundle wheel to measure the diameter of the circle, or you could just start at the middle and measure it outwards. Okay, so we can say radius of the circle, okay, because you can just measure out from the penalty spot. Okay, once that part's done, use the circumference. So you can also use the circumference formula. You can use the circumference formula. L equals 2 multiplied by pi multiplied by radius, or 2 pi r. Okay, so use the circumference formula 2 pi r and see if this result is the same as the circumference measured by the trundle wheel. Okay, so what we're going to do this time is slightly better method. once I thought about it a bit more, 2 pi r. L equals 2 pi r. Use the Trundle wheel to measure the radius. Okay, so you go along here, you measure the radius. Then you multiply this radius by 2 pi. And you get a number. Let's call it x. Then go to the outside of the circle. Use your Trundle wheel to measure around the circle. And see how close this value is to x. If this value is very close or exactly the same as x, this is a perfect circle. If it's not the same value as x, it's not a circle. Okay? So that's the answer to that question. And make sure the two match, okay? Now we're on question 6. Car A and car B set off a starting point S at the same time. They travel the same route to their destination D, which is 70 kilometers away. Car A travels at a speed of 50 kilometers an hour and car B travels at an average speed of 45 kilometers an hour. How far will car B have travelled by the time car A arrives in destination D? Okay, well, first thing we got to do is time equals distance over speed. And in this question, it's 70 kilometers is the distance, and car A is traveling 50 kilometers an hour. So it's going to be 70 divided by 50. And what we get here is 7 over 5, or 1.4 hours. So it's 1.4 hours when A eventually arrives at destination D. Now, distance is also equal to speed multiplied by time. And what happens next is it's going to be 45 kilometers an hour multiplied by 1.4 hours. So 45 multiplied by 1.4. And what we get there is 63. So it travelled 63 kilometers in this time. Okay? So distance of car B will have travelled 63 kilometers. ANS 63 kilometers. Okay? Moving on. Angela leaves home at the following time. So we'll just extend this out a little. Okay, so Angela leaves home H at 5 PM to go to a football practice, which is 700 meters away. Okay, the graph shows her journey on foot to football practice. One of the stories below matches Angela's journey. Place a tick beside the correct box. Okay, so let's see what happens. Angela starts at home. She walks a distance of 300 meters. So 300 meters in 8 minutes. Okay? Then she doesn't move at all because her distance doesn't change. So she stays stationary for 12 minutes. Or sorry, for 4 minutes, because there's 4 minutes in the difference, okay? So stationary for 4. And then she travels from 300 meters to 700 meters in the next 4 minutes. Then she travels 400 meters in the next 4 minutes. Okay. Angela walks at a constant pace and stops at 5:08 for 4 minutes. Okay. So she leaves at 5 o'clock. So I'm just going to put times on this. This one here will be 5:08. So she travels 300 meters in 8 minutes. So that's 5 o'clock to 5:08. And then stationary for 4 minutes. That's going to be 5:08 to 5:12. And then finally 400 minutes in the next 4. So that's going to be 5:12 to 5:16. That's when she's traveling at the end. So 3 different parts. Okay, part 1, part 2, part 3. Angela walks at a constant pace and stops at 5:08 for 4 minutes. She then walks at a slower pace at practice 5:16. She walks at a faster pace because we can see that the slope is much steeper, so she walks at a faster pace. So this part is wrong. Okay. Angela walks at a constant pace and stops at 5:12 for 4 minutes. 5:12. No, she doesn't stop at 5:12. Angela walks at a constant pace and stops at 5:08 for 5 minutes. She stops for 4 minutes, not 5 minutes. Angela walks at a constant pace and stops at 5:08 for 4 minutes. She does that. She then walks at a faster pace and arrives at practice at 5:16. Correct. Angela walks at a constant pace and stops at 5:08 for 4 minutes. She then walks at the same pace. Same pace is incorrect. If it's the same pace, it'll be the same slope. Okay, so we've got the correct one there. Mary also lives 700 meters from football practice but cycles to practice. She leaves home 5 minutes after Angela. So she leaves home at 5:05 p.m. She cycles at a constant pace and arrives at practice 2 minutes before Angela. Represent this journey on the graph. So 2 minutes before Angela is 5:14. So she travels 5:05 to 5:14. 5:05, which is 5 minutes after practice, after 5 o'clock. So here is 5:05, and here is, she travels 700 minutes. She reaches the location at 5:14. It says that she goes at constant pace, which means that her line never changes slope because it's consistent all the way through. So what's going to happen here is this. Okay, so it's from here to here. Okay, so from here to here is how she leaves at 5:05, she finishes at 5:14, and she travels at a much faster rate overall. Okay, now represent Mary's journey on the graph above. Done. Next part. Okay, this is question 7. Okay, question 8. Express in its simplest form 5 minus x over 5 plus x minus 4 over 4. Okay guys, so what we're going to do is the following. Okay, what we're going to do is we're going to look at the 5 and the 4, and we're going to pick a fraction, a close common denominator. So count up in 5s until the number 4 will divide into one of these numbers. The number 20 is what we're looking at. Change 5 into 20. You got to multiply the bottom by 4 and also the top by 4. Change 4 into 20. Multiply the bottom by 5 and the top by 5. So what we're going to have is on the bottom, what we're going to have is 4 multiplied by 5 is 20. And 4 multiplied by 5 is 20. So that's all 20 on the bottom. On the top it's going to be 4 multiplied by 5 is 20. 4 multiplied by minus x is minus 4x. 5 multiplied by x is 5x. And 5 multiplied by minus 4 is minus 20. Now what happens here is the 20s will cancel. And we're left with minus 4x plus 5x, which is going to be x over 20. Okay. Solve for x, the following equation. 3x squared plus 11x equals 4. So what we're going to try out, first and foremost, is bring the 4 over the other side. And we're going to get 3x squared plus 11x minus 4 equals 0. We're going to get the reference number by multiplying the first number by the last number. Reference number equals minus 12. Minus 12 breaks off into two numbers, which is going to be plus 12 and minus 1. So now what we get is 3x squared plus 12x minus 1x minus 4 equals 0. Then we're going to factorize, And when we factorize, we're going to get 3x bracket x plus 4. Second one has to be the same. Minus 1 into x plus 4 equals 0. And this is going to give me 3x minus 1 because into multiply by x plus 4 equals 0. Split it in half. And what we get is either the first number equals 0 or the second number equals 0. So 3x minus 1 equals 0. 3x equals 1. Divide by 3. X equals a third. The next one's going to be x plus 4 equals 0. Bring out the 4. We're going to get x equals minus 4. So the two answers there are going to be minus 4 and a third. Okay. Next one. Divide 2x squared, 2x cubed. So we'll just... Okay, so the next one is dividing 2x cubed plus x squared minus 13x plus 6 by x plus 1. X plus 3. So we're going to get here. We're going to divide this in. So we get 2x cubed plus x squared minus 13x plus 6 divided by x plus 3. Let's see what's going on. Now what you're going to do first and foremost is you're going to divide x into 2x cubed. So 2x cubed is 2 and 3 x's. X is on the bottom, x's cancel, and we're going to be left with 2x squared. 2x squared on the top, multiply in, and what we're going to get is 2x cubed, because 2x squared multiplied by x, 2x cubed. 2x squared multiplied by 3 is 6x squared. Now we're going to take them away. So minus and minus. So we're going to end up with 1x squared minus 6x squared, which is minus 5x squared. 2x cubed minus 2x cubed is 0. Bring down to 13x. Next step is, how much does x go into minus 5x squared? So minus 5x x divided by x, it goes in minus 5x times. Okay? So we're going to multiply 5x by we're going to multiply 5x by x, minus 5x by x, and minus 5x by 3. So we're going to get minus 5x squared minus 5x by 3 is plus 15x. Oh, sorry, minus 15x. We're going to take them away from each other. Take them away, you got to change the signs. So what we get here is 5 minus 5x squared plus 5x squared is 0. Minus 13x plus 15x is plus 2x. We then bring down to 6. Okay. And then 2x plus 6 divided by x plus 3. So it's going to be 2x divided by x, which is twice. 2 multiplied by x is 2x. 2 multiplied by 3 is 6. Then we're going to take them away. What happens is changes from plus changes into a minus, and we get 0. So this is our answer here. Okay. Next question. A company employs 2 drivers, John and David. Each has use of a company car and small van. The company buys €30 worth of toll tags for each driver. Each time that a vehicle goes through the M50 toll, a charge will be deducted from the toll tags. John goes through the M50 toll 5 times in his car and 4 times in a small van. He then has the €7.90 remaining on his toll tags. David goes through the M50 toll twice in his car and 6 times in a small van. Then he has €8.40 left on his toll tags. Calculate how much it costs for a car and a small van to go through the M50 toll. Okay guys, so how much it costs for the car, let's call that X, and how much it costs for the van to go through, let's call that Y. Now, company buys €30 worth of toll tags, okay, for each driver. Each time a vehicle goes through the M50 toll, a charge is deducted from the toll tags. John goes through the M50 toll 5 times in his car. So that's 5 multiplied by the charge in a car, and then he goes through it, and then he goes 4 times in a small van. So it's going to be 4 multiplied by the amount of cost in the small van, and that has to equal €30 minus his €7.90 remaining. So he has €7.90 remaining from €30, which will give us his total cost. So 30 minus 7.9, and that will give me 22.1. So 22.10 for that one. Okay, now we're on to the next equation. David goes through the M50 toll twice in his car. Twice in his car is 2x. 2 multiplied by the cost per time in the car. And 6 times in a small van. So that's going to be plus 6y. 6 times multiplied by the cost in a small van. He has €8.40 left on his toll tag. So it's going to be €30 minus €8.40. What we get here is we get €21.60. Okay. Now, what we gotta do next is we need a way to, this is a simultaneous equation, and we need a way to solve this, okay? So what we're gonna do first and foremost is we're going to multiply, we're gonna choose which letter to get rid of. So I'm gonna get rid of the y's, okay? So 4 sees the number 6 and 6 sees the number 4. So I can do on the top one is I can multiply this one by minus 6 and the bottom one by 4. And look what happens now, okay? So we're going to get, multiply this by minus 6, we're going to get minus 30x minus 24y. And then we're going to get 22.1 multiplied by 6. 132.6 equals 132.60, and then the next one's going to be multiplied by 4, which is going to give me 8x plus 24y equals 4 multiplied by 21.6. What that gives me is 86.4. Now remember, this one here is negative, this one's positive, so let's see what happens now. Add downwards, the y's disappear as expected, and we're left with minus 22x, because minus 30x plus 8x minus 22x equals minus 132.6 plus 86.4, and that will get me 46.2. Minus 46.2. Now I have to do next is I got to multiply both sides by minus, and I'm going to get 22x equals 46.2, 0, and then I'm going to divide it by 22. So 46.2 divided by 22, it's going to be 2.1 or €2.10. X equals €2.10. Now I have to figure out what y is, okay? So to figure out what y is, I'm just going to use this equation here. It's going to be 5 times €2.10 plus 4y equals €22.10. Multiply 5 by that, we get €10.50 plus 4y equals €22.10. Take away the €10.50, and we're going to get us 4 off the van's toll charges. We'll get us 22.1 minus 10.50. And that will get us is 11.6. Now we're going to divide 11.6 by 4. And what we get is the fan charge is €2.9 or €2.90. Okay guys.